Now look at 4.24. When photons of energy 25 electron volt strike the surface of a metal A, the ejected photoelectrons have the maximum kinetic energy Ta electron volt and de Broglie wavelength lambda A. So from the statement you clearly understand this is related to photoelectric effect. Think of the Einstein's equation, h nu equal to h nu naught plus Ke. Then the maximum kinetic energy of photoelectrons liberated from another metal B by photons of energy 4.7 electron volt is Tb equal Ta minus 1.5 electron volt. If the de Broglie wavelength of these two photoelectrons is lambda B equal to twice of lambda A, then four of the options are given and you have to identify the correct one. So simply thought process क्या होना चाहिए? There are two metals A and B on which the photoelectric emission is taking place and few data is given. First data, photons of energy 25 electron volt strikes. मतलब if I consider this as my metal plate, the energy which strikes is equal to h nu. Strike करने के बाद it will first ionize, increase the energy associated with the metal, and that particular energy is the work function equal to h nu naught. And then if the energy is sufficient to remove the electron, it will move with a kinetic energy of half mv square. So as per law of conservation of energy, this h nu will be equal to sum of h nu naught and k. Correct? So in the first case, photoelectron the energy 25 electron volt is h nu. Can I say it? Then it strikes the surface of metal A. The ejected photoelectrons have the max kinetic energy equal to Ta electron volt, and the de Broglie wavelength is lambda A. De Broglie wavelength is lambda A. ठीक है? Next case में the max kinetic energy here is Tb, and there is a relation which is given for Tb and Ta. It is Ta minus 1.5 in electron volt only, and इस case में the energy striking is 4.7 electron volt. Okay, sorry, one correction is there. This is not 25, it is 4.25. 4.25. Correction करते जाओ, 4.25. And here the de Broglie wavelength is lambda B. Now if you look at the four options given, you are supposed to find the W naught, meaning the work function of A, and the work function of B is to be found, and Ta and Tb, the kinetic energies, are to be found. Now, what do you think is the de Broglie wavelength being given? And the relation is also being given between them, that lambda B is equal to twice of lambda A. How can you use this relation in association with any other parameter? De Broglie wavelength. De Broglie's wavelength है, what formulas tell me? De Broglie's wavelength का सबसे basic formula is h upon the momentum, which is h upon mv. We converted this into kinetic energy, h upon root of 2 ke into m, right? So now the lambda, the de Broglie wavelength, and the kinetic energy is related. And in both the cases, the electrons are being striking the metal plate, मतलब m is constant. So solution में what you have to start with is lambda, or the de Broglie wavelength is h upon root of 2 ke into m. That is, lambda will be inversely proportional to root of the kinetic energy. So lambda of A upon lambda of B will be equal to root of kinetic energy B upon A. The kinetic energy B क्या है? Tb, और A क्या है? Ta. Correct. So lambda A by lambda B, ये relation मिल गया. Also there is the relation of lambda A and lambda B given. Lambda B by lambda A is 2. So यहाँ पर ये twice of lambda A already लिया है. So root of Tb by Ta. So finally if I square them, it will be 1 by 4. This gets cancelled. Is equal to Tb by Ta, and therefore Ta will be equal to 4 times Tb. Is this clear? Simple de Broglie's wavelength kinetic energy relation, you get this as per the lambda relation given. तो आपको स्ट्राइक हो जाना चाहिए ये डेटा क्यों दिया था, so that you can use it to get the relation of kinetic energy. One more data was given. TB is equal to TA minus 1.5. TA is 4 times TB minus 1.5. So this will be thrice of TB equal to 1.5. Therefore TB will be equal to half इलेक्ट्रॉन वोल्ट ही रहेगा, एंड इससे TA 4 गुना है मतलब 2 इलेक्ट्रॉन वोल्ट. ठीक है. नाउ मैच द ऑप्शंस TA एंड TB. इज इट 2 इलेक्ट्रॉन वोल्ट एंड 3.5? 2 इज ओके, 3.5 गलत है, मतलब फोर्थ ऑप्शन उड़ गया. बराबर. अब you also have to find the work function. Now the Einstein's equation for photoelectric effect is H nu equal to W plus kinetic energy half mv square. So in this case H nu is given, W we don't know, but kinetic energy now we know for both of them. समझा? तो केस 1 अगर A के लिए ले तो 4.25 is given H nu equal to W of A work function plus kinetic energy A का कितना है 2. Subtract करो, you get the work function as 2.25. Is it matching? Okay, that is also correct. Secondly, you again use it for B. 4.7 equal to W of B plus 0.5 subtracted, you get the work function B as 4.2. Is it matching? मतलब 4 ऑप्शन में से 3 of the options were correct, 4th was wrong. Hence the answer will be 1, 2, 3 option C. 4.27. Calculate the wavelength and wave number, which is simply the reciprocal of wavelength of the spectral line when an electron of hydrogen atom falls from a higher energy state n equal to 3 to n equal to 2. So how do you calculate the wavelength when the transition is given? Rydberg's formula. ठीक है, खत्म. आगे. Also determine the energy of a photon to ionize this atom by removing the electron from second orbit. Ionization enthalpy. So whatever is the En का formula, minus of that is ionization energy, plus आएगा बस. ठीक है. Compare it with the energy of photon required to ionize the atom by removing the electron from the ground state. मतलब इस केस में the n का value is to be taken as 1 and minus of En is the answer. समझा? तो कुछ है ही नहीं क्वेश्चन में एक्चुअली. सो 3 चीजें जो यहाँ पर पूछी थी. फर्स्ट वन was the wave number and the wavelength, which was equal to R into Z square 1 by N1 square minus 1 by N2 square. What is R value to be taken? Plus 7. 1.1 into 10 raised to plus 7 per meter. You will get the lambda in meter. ध्यान रखना. हाइड्रोजन एटम है तो 1 square. ट्रांजिशन 2 to 3 है मतलब 1 by 2 square 1 minus 1 by 3 square. Calculation is okay. You can handle that. ठीक है, बट याद रखना the answer will come in meter. You can get it in centimeter, angstrom, whatever is required as per the options. Secondly, ionization enthalpy जब भी पूछा जाए, it is simply equal to minus of En, and minus of En becomes plus 13.6 into Z square by N square in electron volt, and that too electron volt per atom. मान लो अगर जूल्स में पूछा जाता तो a direct expression of this was also given 2.18 into 10 raised to minus 18. 2.18 10 raised to minus 18. That's how you remember. Into Z square by N square joule per atom. मान लो जूल पर मोल बोला तो into Na कर देना है. So units ध्यान रखो. 13.6 gives you an electron volt. 2.18 into 10 raised to minus 18 gives you in joules per atom. If you want in per mole, then multiply Na.
Divide by 4.2.
4.18 for 4.2. Perfect. ठीक है. So for the second ऑर्बिट का आयोनाइजेशन एनर्जी यहाँ पे 2 स्क्वायर डाल देना है, मतलब डिवाइड बाय 4 हो जाएगा, और फर्स्ट यानी ग्राउंड स्टेट जो है उसके लिए 1 स्क्वायर, z इज एनीवेज 1, और कंपेयर मतलब यू हैव टू जस्ट टेक द डिफरेंस, खत्म। 4.28 A hydrogen atom in the ground state is hit by a photon exciting the electron to the third excited state. What is that? Fourth energy level. Very important. Third excited state is fourth energy level, matlab n equals to 4. The electron then drops to the second orbit. So n is equal to 2. What is the frequency of radiation emitted and absorbed in the process? Frequency of radiation. Now, when there will be emission and when there will be absorption? The two energy levels are 2 and 4. Emission कब होगा, absorption कब होगा? Excitation में एनर्जी एब्सॉर्ब होगा तब जाके 2 से 4 पे जंप करेगा ना, और 4 से 2 पे आएगा तो रिलीज होगा, बस समझा? क्लियर है? तो इसमें भी कुछ नहीं था। थर्ड एक्साइटेड स्टेट इज फोर्थ एनर्जी लेवल, second orbit is already given, emission happens when the electron jumps from lower to higher, absorption happens when electron jumps from lower to higher, and emission के लिए उल्टा। और फ्रीक्वेंसी फाइंड करने के लिए 1 by लैम्डा तो आपने फाइंड किया है, उसको मल्टीप्लाई करो बाय c by लैम्डा इज द फ्रीक्वेंसी, अंडरस्टूड? ठीक है, हाँ, एक एमिशन के लिए और एक एब्जॉर्प्शन के लिए। ओके, नाउ 4.30 ये एक अच्छा क्वेश्चन है। There are lot of things which are asked. Obviously in the actual question these many things won't be asked. इसमें से कुछ पार्ट यहाँ पर पूछ सकते हैं, but this is kind of subjective question to understand the concepts. ठीक है? 4.30 A single electron. Now the moment they say single electron,
H.
हाँ, हाइड्रोजन या हाइड्रोजन लाइक स्पीशीज मतलब बोर्स मॉडल। सी, अब हम कर रहे हैं एटॉमिक स्ट्रक्चर, हमें पता है कि ये कहीं ना कहीं उससे रिलेटेड है, बट जब ये क्वेश्चन स्टैंडअलोन आएगा तो आपका थॉट प्रोसेस उधर ही शुरू होना चाहिए। सिंगल इलेक्ट्रॉन दिया है मतलब हाइड्रोजन लाइक स्पीशीज यानी बोर्स ऑर्बिट, यानी बोर के जितने भी फॉर्मूलाज है सब आपके दिमाग में आ जाने चाहिए, समझा? A single electron orbits around a stationary nucleus of charge plus ZE. Now a nucleus with a charge plus ZE, what does the Z represent? The atomic number. Because for any atom, जो भी उसका प्रोटॉन्स का चार्ज है उतना ही इलेक्ट्रॉन का चार्ज होता है, बट इक्वल मैग्नीट्यूड के साथ, ऑपोजिट साइन के साथ, ठीक है? Where Z is a constant, so they have not given that Z is an atomic number, but that is something to be understood. And E is the magnitude of electronic charge. It requires 47.2 electron volt to excite the electron from the second Bohr orbit to third Bohr orbit. Find the value of Z and बाकी सारी चीजें और पूछी हुई है, ठीक है? तो just cut down to first part first. Find the value of Z.
So En से Rydberg's possible.
En से?
En is equals to Rydberg's का formula डाल के.
But that is for 1 by lambda. 1 by lambda. The difference of the energy is given.
Delta H. Delta E is
हाँ, delta E. Delta E equal to hc by lambda वाला expression, बराबर? Now listen, ये formula सिंपली है, En is minus 13.6 into Z square by N square electron volt. So if I take delta E, then 13.6 into Z square तो constant हो जाएगा, into 1 by N1 square minus 1 by N2 square. If you remember, this expression we had derived using this relation only. So what you have to use is simply delta E equal to 13.6 Z square 1 by N1 square minus 1 by N2 square. Now you know delta E given, Z is something to be found, N1 N2 दिया है, खत्म, समझा? तो कैलकुलेशन आप कैसे करेंगे? 47.2 equals to 13.6 Z square into 1 by 2 square minus 1 by 3 square. So 47.2 and 13.6. 13 4 जा नहीं जाएगा. 13.6 into 3, 18, 10 and 40, 40.8 और उसका हाफ, तो अराउंड 3.5, 3 and 4 के बीच में equals to z square. ये पार्ट कितना आता है? 9 minus 4, 5 by 36, right? So z square would be equal to 36 times 3.5 upon 5. So 5 into 7 almost, and 7 3 21 or half, almost 25. So आपको nearest value चाहिए था ना, z should be equal to 5 related with boron atom. Now just tell me बाकी के लिए क्या relation use करेंगे. B part. Find the energy required to excite the electron from 3 to 4. Now we know Z. So 13.6 into 5 square, 1 by 3 square minus 1 by 4 square. Khatam. C. Find the wavelength of radiation to remove the electron from the second Bohr orbit to infinity. Wavelength. अब Rydberg's 1 by lambda. जब एनर्जी दिया है तो ये यूज करो, जब वेवलेंथ पूछा है तो Rydberg's एक्सप्रेशन, बिकॉज डेल्टा ई के थ्रू ही हमने ये डिराइव किया है, ध्यान रखना. Then D part. Find the kinetic energy, potential energy and angular momentum of the electron in the first orbit. Now, how do we find kinetic energy? That is okay, but direct relation भी है. हाँ, what is PE-KE relation?
Kinetic energy is minus 2 times potential energy.
PE is minus 2 of KE and KE is minus of the total energy, और total energy EN होता है. अब फर्स्ट ऑर्बिट में आपका EN कितना होता है? minus 13.6 into 5 square upon 1 square. इलेक्ट्रॉन वोल्ट में मिल गया? Yes or no? So the kinetic energy, this is actually, ठीक है, kinetic energy is minus of T and P is equal to minus of 2 K. That's it. And angular momentum ढूंढना है तो MVR is equal to N into H upon 2 pi, which is 1 into H upon 2 pi. H upon 2 pi directly पता है, H upon 4 pi पता है, बस. मतलब can I also write it as 2 H upon 4 pi, which will be equal to 2 into 0.53 into 10 raised to minus 34. खत्म. Answer is 1.06 into 10 power minus 34. These are the ways you need to simplify. अब यहाँ पे H और pi की वैल्यू क्यों सब्स्टिट्यूट करनी है? You know H upon 4 pi. And find the ionization energy of above electron system in EV. हाँ, above electron system मतलब ionization energy find करना है. ये above electron system आपका कौन से ऑर्बिट से कौन से ऑर्बिट तक है? सेकेंड बोर ऑर्बिट टू द थर्ड बोर ऑर्बिट. तो 2 से इंफिनिटी वाला फाइंड करना है, यानी इसी एक्सप्रेशन में आपको n की वैल्यू 2 डाल देनी है. हाँ, आयोनाइजेशन एनर्जी फाइंड करना है तो माइनस ऑफ En लेते हैं. सो इट विल बिकम 13.6. Z स्क्वायर इज नाउ 5 स्क्वायर अपॉन n स्क्वायर, जहां से वो इंफिनिटी पे जाने वाला है. 4.31 इज अ गुड क्वेश्चन, वेरी गुड क्वेश्चन. सिंपल है बट अच्छा क्वेश्चन है. लिसन, फाइंड द एनर्जी रिलीज्ड इन जूल्स व्हेन अ डबली आयोनाइज्ड हीलियम आयन. डबली आयोनाइज्ड मतलब both the electrons of helium are being removed and they have already given Ha with a 2 plus. In case not given, please understand doubly ionized मतलब removal of 2 electrons. So Ha 2 plus is the species given. Takes up 2 electrons to form a helium atom. Takes up 2 electrons to form a helium atom in the ground state, meaning N is equal to 1. Just try converting the given data in form of expressions. आसान हो जाता है. Now, the first ionization energy of helium atom is 3.4 into 10 raised to minus 19 joule. First ionization enthalpy means रिमूवल ऑफ फर्स्ट इलेक्ट्रॉन. मतलब हीलियम से when you convert to He plus with the loss of one electron, the energy is 3.4 into 10 raised to minus 19 joules. समझा? तो क्वेश्चन आपको पूछा है कि इस रिएक्शन के लिए या प्रोसेस के लिए how much is the energy being released. Now this is simply the expression related with 2 electron का gain. तो पहले 2 इलेक्ट्रॉन का लॉस देखते हैं. तो फर्स्ट का लॉस इज दिस मच एनर्जी. सेकेंड लॉस मतलब He प्लस से इलेक्ट्रॉन निकाला तो He2 प्लस डबल आयोनाइज्ड हीलियम आ गया. If I add up, this is your intermediate. So helium would overall lose 2 electrons to form He2 plus. अब इसका उल्टा आपको पूछा है तो एनर्जी जो भी आएगा उसका निगेट करना है. समझा? अच्छा, now we have to just find this energy. How do we find? He plus is losing the electron to form He2 plus. Ionization energy. Now bohr के लिए what type of species are applicable? What were the single electron species? Hydrogen, helium plus, lithium 2 plus, beryllium 3 plus. बस बराबर. मतलब ये जो एक्सप्रेशन है that is simply the expression related to ionization energy for the single electron species. समझा? यही सबसे बड़ा हिंट था और कुछ नहीं है इसमें. अब to find the ionization energy I have to take minus of En. Now if you see the value it's in joules. So what expression would I take? 2.18. You remember 2.18 into 10 raised to minus 18 into what is Z? 2 square. Helium species, huh? So 2 square by in which state? In the ground state. Ground state. So 1 squared. Hence it will be 4 into 2.2, almost 8.8 into 10 power minus, which I can write as 88 into 10 raised to minus 19 joules. Just converting to this particular value. अब दोनों को ऐड करोगे तो कितना आ रहा है? 91.4. That is the answer. Just निगेट करना है क्योंकि रिलीज्ड एनर्जी हमेशा नेगेटिव होती है. समझा? This is the energy for the second process. The energy for first process was given. Total energy कितनी हो गई? 88 plus 3.4. 91.4. This is the energy which is being absorbed क्योंकि ये I है और आपको पूछा है EA इलेक्ट्रॉन एफिनिटी. समझा? माइनस क्योंकि एब्जॉर्प्शन में एनर्जी देनी पड़ती है और जब इलेक्ट्रॉन गेन होता है तो एनर्जी रिलीज होती है. So it's 91.4. They are getting as 90.2. That's okay.
अच्छा तो सर He plus तो उसको आपने ब्रेक किया. हाँ,
2 प्रोसेस में. पहले He से He plus, फिर He plus से He2 plus. तो ये प्रोसेस के लिए एनर्जी हमें एक के लिए दिया है, दूसरे के लिए बोर का एक्सप्रेशन. Now for this, if the energy is E, for the reverse, the energy will be minus E. So energy absorbed अगर मैं लिखूं तो it will be equal to 88 plus 3.4 into 10 power minus 19 joules, right? और जो आंसर आएगा उसको निगेट करना है. Now here they have not considered the sign, but in the options if the sign is considered, the answer will be negative of whatever value you have got. ध्यान रखना. In the options if they have given 2 magnitudes but the sign is also being given, then the correct answer will be with the negative sign. 4.32. 1 mole of He plus ions is excited. 1 mole मतलब they have considered Avogadro number of species. And the moment they say He plus ions मतलब बोर का मॉडल ही चल रहा है. An analysis showed that 50% of ions are in the third energy level. 50% of the 1 mole is in the third level. 25% again of 1 mole are in the second energy level, and the remaining are in the first energy level. मतलब if I talk about the He plus species, 1 mole is present for the first energy level ground state, second energy level and third energy level. The distribution is 50% here, 25% here, and remaining is obviously 25% in the ground state. This is what is given. Calculate the energy emitted in kilojoules when all the ions written to the ground state. All the ions written to the ground state matlab what are the possible transitions? 3 to 1, 2 to 1. तो 25% जो ऑलरेडी ग्राउंड स्टेट में है वो एनर्जी हमें कंसिडर नहीं करनी है. करेक्ट. सो एनर्जी फाइंड करने के लिए when the transition is from 3 to 1, what is the formula you'll use? Delta E. So again, what is delta E? Directly now can you remember? It will be 2.18 into 10 power minus 18 into z square 1 by n1 square minus 1 by n2 square. So delta E for 3 to 1 transition, it will be equal to 2.18 into 10 power minus 18 species helium plus m matlab 2 square, and the transition is 1 by 1 square minus 1 by 3 square. But इतना ही नहीं, multiply by Na का 50% मतलब 0.5 Na, because 3 to 1 transition is happening for 50% of 1 mole. So this needs to be multiplied by 0.5 Na. हाँ हाँ ये हाफ हो जाएगा. अब दूसरा ट्रांजिशन क्या था? 2 से 1. इट विल बी 2.18 into 10 raised to minus 18 into 2 square 1 by 1 square minus 1 by 2 square into 0.25 times Na. अब टोटल एनर्जी फाइंड करना है तो यू हैव टू जस्ट ऐड अप. लॉट ऑफ थिंग्स आर कॉमन, जस्ट टेक इट. So 2.18 into 10 raised to minus 18 into 0.25 Na. पूरा कॉमन हो गया. This into 2 square भी है. This and this सब कॉमन निकाल दिया. तो अब बचा क्या? Into यहां पर आएगा 0.25 बचेगा. So 1.25 into इसका डिफरेंस 8 by 9 प्लस ये डायरेक्टली खाली डिफरेंस लेना है 3 by 4. खत्म. What you will get here is joule per mole. उसको किलो जूल्स के लिए 10⁻³ करके कन्वर्ट कर देना. Now 4.34. Determine the frequency of revolution of an electron in the second Bohr orbit in hydrogen atom. What is frequency? Cycles or number of revolutions per second. Per second मतलब it is reciprocal of time. Now how do we measure time? Speed is equal to distance upon time. So if an electron is revolving in a particular orbit, how much is the distance covered in one revolution? 2 pi r. So we know the distance is 2 pi r. The time is taken as t, and the velocity in the nth orbit is vn, and the radius of the nth orbit is rn. So what is frequency now? 1 by the time. Matlab it is equal to vn upon 2 pi rn. Now do we know Vn for the second orbit and Rn for the second orbit? क्या देख रहे हो? पता है ना? हाँ, Vn के लिए 2.2 into 10⁻⁶ into Z by n meters per second. Rn is 0.53 into n square by z. लेकिन प्रॉब्लम एंगस्ट्रॉम में है. If I am taking this in SI unit, it has to be 10⁻⁻10 meters. यहाँ पे यूनिट का कन्वर्जन इंपॉर्टेंट था. बस you know Z and you know N. Z is हाइड्रोजन एटम ही है. Yes, 1 and second Bohr orbit मतलब N is 2. The substitute frequency मिल जाएगा.